graphing to make sure that you feel good about it. In today's lesson, we're going to use the unit circle and all that stuff we did yesterday. On your test on Friday, your graphing will be the main application of the unit circle stuff, okay, that we talked about as far as angles that work out nicely. So, yeah, let's do it right now. Here we go. Okay, so my goal for today is to get through 2 of these today. That's the goal. So let's do it. So today is May the 26th, 2015. Graphing sinus little functions. Okay, and there actually is no note today. Today we're just doing 2 examples. Here we go, example 1. All right, if you remember back from grade 11, and if you remember back from grade 11 and advanced functions, these are periodic graph sine and cosine. What does a periodic graph mean again? It goes on infinitely big forever and ever and ever, okay? So I will tell you on your graph what to graph it from where to where. All right, because if not, then you can graph it for as small or as little as you can. Like you could literally say, hey, my name's Matt, I want to do this as my graph, and I would say, yeah, well, that's technically the graph. All right, so I will tell you on your test to graph it, you know, either over a certain cycle or over a certain amount of time here, okay? So, okay, this is going to be the same as, okay, so this is going to be the same. I want to go fairly quickly today if I can. This will be the same stuff I'm expecting as we did the last unit. What was the first thing we needed for a graph for the last unit? Domain. What's the domain for this? You can either say from 0 to 2 pi or anything. Either one of those will work for me. Okay, I want to grade a graph from 0 to 2 pi, as long as you say these will go on forever. The only thing that would cause a restriction would be what? What would cause a restriction on one of these graphs? Asymptote. What equation will have an asymptote? And hint, your assignment, hint, okay? So there's going to be lots of issues with that graph on your assignment. Okay, intercepts. On your question, do I graph can? Okay, for my intercepts here, I'm going to actually put 2 points in here for your intercepts, okay? I'm going to start off here. I'm going to use both edges of my graph here. So I'm going to use 0. I'm also going to use 2 pi. The reason for that is so you start and end. Even though it's not really an intercept 2 pi, we're going to plot that last point anyway, okay? So now here's where our nice unit circle stuff comes in. What is sine of 0 equal to? Good. What is cos of 0 equal to? Good. So 0, 1. And for fun, we'll put 2 pi in here as well. Sine of 2 pi is going to be 0. Good. And cos of 2 pi is? Yeah, so it's the same thing. They're going around the circle. I just want to put those on there so we have a beginning and an end to our graph there. Now, I did that very, very fast, and I apologize. People come to me and said they sort of get the unit circle, they sort of don't. Are we okay on where that came from? The 0s and the 1s? No, the... I should have realized. All right, asymptotes to this graph is what? Asymptote to none. All right. All right, here we go, f prime of x. Okay, can I get somebody to be brave and just tell me what f prime of x is equal to, please? Evan, go. Cos of x minus sine of x. All right. How do you solve this equation? What do we do to find critical points for this one? Set equal to 0. Okay. So 0 equals cos x minus sine x we want to know when sine x equals cos x, or if we really want to go crazy, we can call that when tan x equals 1. That's what we're looking for. All right, so let's think on the even circle here. If you want to do the sine x equals cos x, and when does sine x equal cos x? Pi over 4. Okay, so x is equal to pi over 4, definitely. Now, if you don't know how I'm getting that, let me write this out. I shouldn't be so good here. Okay, the reason that is, right, because this is the point, again, if you take a look, using a special triangle, right, we're going to have the same values here. What's the other angle going to be equivalent to pi over 4? Stay with me here, please. Stay with me here, please. What's the other angle that's also going to have a slope of 1? What's that? I heard somebody say 5 pi over 4. How did you say that? Okay, good. Everybody said it, okay? 5 pi over 4, there's an identity for that, but also think it as a slope of 1. That's the idea, okay? So again, cast rule, CAST. Right, okay, so that's also going to be, so that's going to be 4x equals 5 pi over 4. All right, sort of okay. Ben, how are you feeling? Great. Can I ask you a personal question here? Sure. If you hate the book Harry Potter, why do you wear a Gryffindor shirt? I thought you said that was just random. Okay. The next thing I should do then is I should find out what f 5 by 4 equals. Okay, I'm going to show off my math skills and not use the calculator for this. This is going to be then sine of pi by 4 plus cos of pi by 4. What is sine of pi by 4 equal to, please? What? Sorry? Root 2 over 2. That's what's going to, yeah, what is root 2 over 2? I'll use this one. My point then is going to be pi over 4. That's very okay. That was 100 miles an hour. I'm going to slow down from here on out. Okay, so what I did was I said, well, sine of pi by 4 is equal to 1 over root 2. All right. Cos of pi by 4 is equal to 1 over root 2. Adding together, that's 1 over root 2 plus 1 over root 2 is 2 over root 2. And then I just rationalize to get root 2. Again, if you use Michael's version, it would probably be easier. Root 2 over 2 plus root 2 over 2 is just root 2. Yeah, no question? We're back, yeah. All right, the 5 pi over 4 is a little bit more difficult, but not too bad. Okay, so I'm going to say f of 5 pi by 4 is going to be what? I'm going to use that circle to get what, so I'm going to say, do it again here, sine of 5 pi by 4. Right here. Okay, how am I going to get what sine of 5 pi by 4 is? Oh, this is scary. Not Michael. I'm not really scared of Michael. Okay. Okay, so you can think back to yesterday's lesson if you need to. Okay. So what I'm going to do is I'm going to flip it up to this quadrant. And then flip it over to here, okay? So this is just going to be negative sine pi over 4 plus actually minus cos pi over 4. So since it's just minus, that's going to be negative root 2. Excuse me. On your assignment, there's a question. I think you have to graph cos 2x plus sine x or something like that. Something close to it like that. Okay. When you get that question, I expect answers that are nice and beautiful and exact like this. And you don't want to see 1.41. Okay. I want to see root 2. If that was happening to your question. That makes sense what I'm saying there? I hope. Is this sort of making sense? I see a lot of people struggling, which means we're going too fast.
What would the period of this function be?
2 pi. Okay, because just plain old x. One thing I should also mention, let's say that I'm going to pick on Arden. Okay, I don't know if you know this about Arden, but she's awful at the unit circle. Okay, she doesn't like when I say pi, she just goes, I don't even know what he's talking about. Okay, so let's say that Arden's afraid. You're not, by the way. Arden's excellent at the unit circle. Okay, but let's say she was afraid. She could call this answer 2.34, 1.41, and she'd lose half a mark. Okay, right. So if you're willing to, if you're willing to lose half a mark, then do it that way. Okay, right. But just for your future in university, right, you should really do the question with no calculator. Does that make sense? What I'm saying there for that, right? You don't lose that half mark. Sorry, I didn't do very well. All right, so I have 2 points. I'm going to highlight these because we're not even close to getting on this question. Okay, what else do I need then after this? The F double prime. That's going to give me my F double prime of x. If F prime of x is equal to this, someone other than Evan, sorry, Evan, you're out. Give me F double prime of x, please. Okay, go ahead.
Minus sin x.
So where I got that from was the derivative of cos x is negative sin x. The derivative of sin x is cos x, and they're both negative, so it goes like that. I'm going to solve this equation. I'll go to the next page here. Are we okay, sort of, what's happened with that? And I'll go quickly here. Oh, good question. I went too quickly here. So make sure to stop and write it down first. Right, because you're just doing divided by cos x divided by cos x. And sine over cos equals. Showing off the pipes and math class. All right, I'm going back to units. Back to the units here right now if you can. All right, so if you don't, this is optional. If you don't want to draw this, you don't have to. Okay, -1 slope is going to look something like this. Okay, what are my 2 angles going to work for that? Okay.
3 pi over 4.
Yes.
And then 7 pi over 4.
Okay, so if you go back to my question here, then I'm going to say f of 3 pi by 4. Is a plus.
Please excuse the interruption. Just a note from the Colossa rugby tournament. St. Mary's was victorious in the semifinals, beating Paris 12-0. They will play West Hill in the finals after. So go Mustangs, go.
And just, they killed, not that you care probably, but they killed West Hill when they played the Musketeers. Killing them. The first game, the championship game.
Oh, championship is
This is the St. Mary's slam I'm trying to take on this, okay, so, yeah. Okay, so what happened was here I did sine of 3 pi by 4 and cos of 3 pi by 4, right? I'm going to do the same thing with 7 pi by 4. Okay, so it's going to be f of 7 pi by 4 equals sine 7 pi by 4 plus cos of 7 pi by 4. Using cast again here. The sign is going to be negative. that right? I think that's right. Is that right? That is right. Okay.
On a test, would you want us to write all the steps?
Probably not. If it's okay, if you can do it and it sort of makes sense to you, then that'd be okay, because this is gonna take a while, right? So, yeah. As far as what I probably want you to show me is, you could do this, blah, 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 that'd be fine, right? Really show me where the two angles are coming from and all that stuff. Okay, any serious questions about this? I know there's some questions about the unit circle here, okay, and I sort of, the first one did nice and slow, the second did a lot quicker, okay, but that's sort of what I hope that you're getting to the point for the second set of numbers, okay. The nice thing with this one is because it's pi over 4, all right, it's very easy because there's not difficult angles, 30 and 60, you gotta be careful which one you're using, right? For this one, it's always 1 over root 2, so it works a little bit better, not better, nicer. All right, good? Okay, let's do this then, interval chart. Now, the nice thing about this, at least I'm going to say it's nice, is this is a periodic graph. So there's the interval chart. Yes.
I have a question about your notation. When you put less than or equal to, can it just be less than?
Yes, you're correct, of course. You know what bugs me with that? Not that you're right, but the problem is that I spent so long on my note getting those less than or equal to signs on my chart. Like, it took me like 10 minutes to get it to work properly on my graphs. I thought, yeah, I just wasted 10 minutes of my life right there. All right. Ah. Of course, you're right there. Okay, for that. Yeah. Because the equal sign right in the middle. Thank you. Okay, so just like before, we're going to do the f prime of x and the f double prime of x in the shape. And again, I should, for the people whose tests I've marked, which is most of you, people did a great job on the graphs, okay? I was really, really proud of you guys. Your intervals, the interval charts were great. People even put, like, on the right-hand side of it, like, test point, they labeled for me, so that I could see what I was checking. The thing about this, because it's periodic, you know it's going to repeat, right? That's the thing, okay? So there's no tricks in these graphs. They're going to be, they're going to repeat for sure. We're going to put our zeros in, put a few test points, and fill in the rest of the chart very, very quickly. All right, this test will not be 3 pages like your last test. Okay, we'll be a little bit more involved. Okay, so I will give you a formal test review on Thursday, right, for what proof is going to be on it and all that stuff. Right, so, you know, you guys had like tons of time. Tracy, how are you?
Oh, just to see it.
Yes, he is. Benny. I call him Benny, by the way, he likes that name, so. Okay, so we're going to put our zeros in here. Now, this is a thing that you should be thinking about for the graph. Every single graph we dealt with is the same, okay? The zeros should go in between each other, okay? So when you see a graph, let's say your graph was like this, okay? you know there'd be an issue there. That isn't right, by the way, okay? But the thing is, there should be balance to this, okay? So the people who got their graphs wrong, their graph looks something like this. It was mixed up, all right? So the way it should go, excuse me, what are my zeros here? 5 by 4 there, and 5 by 4, and then 3 5 by 4, and 7 5 by 4. All right, so it has to sort of zigzag, okay? That's what this should look on here. So what I'm going to do for my test points, I'm just going to choose this and this, and I'm going to fill in the rest automatically. All right? How can I get away with that? Actually, I might not even do that. I might even use pi. Yeah, I'm just going to choose this one and this one, actually. And I'm actually going to use pi. That's what I'm going to use, because that I can do in my head. Okay, how can I get away with that? Well, because this is periodic, so it's just going to repeat. These graphs are, okay? And they're just going to alternate, they're just going to flip. All right, so this interval chart is just not meant to slow you down, although I'm sure it unfortunately will. Okay, but the idea is that you don't have to check 59 points along the way here for this. These are going to repeat. The only time they will not is if you see, and I'm not going to do this to you on your test because they're crunched for time, but in calculus and university is if you get something like a double root or something like that, that's when things are weird. Because if you think back to advanced functions, right, you get a graph that goes like this, and then the derivative of that is going to be weird. Okay, right, because weird things happen, but other than that. So I'm going to choose f prime of pi and f double prime of pi. If I go back to my graph here, f prime of pi, here's my f prime of x. Cos of pi is equal to what? -1. And cosine of pi is equal to? 0. Thank you, 0. Okay. So this is, where does Tony start when I need him here? Okay.
Why did you do?
Oh, I did this because these are the only ones that I'm checking. That's the test one that I'm checking.
Okay.
After that, I'm going to fill in the rest on there. Okay, and so that's, I just want to stress that one just for your guys' note. I'm having real problems with that. Let's do this. There we go. All right. Okay, on the next graph here then. Where's f prime of x? Good. So f double prime. So f double prime of x is negative sine x minus cos x. So sine of pi we already said was equal to 0, and cos of pi is equal to -1. So 0 minus -1 is a plus. So now you can pick any point along here that you want, okay? The reason I chose this is because pi is easy to do in your head with no calculation. Now, can anyone guess how the graph's going to go? This is going to go negative, negative, negative. What's this value up here going to be? Good. What's on my chart? That's it. Ah! Okay, so then we're just going to go plus and plus and plus. There will be another point that goes to negative. That's why I'm stopping this at 2 pi. Because it's repetitive, it'll repeat at a certain point after that, okay? Okay, since this is a plus, I'm just going to say that's a plus and a plus, that's a negative, and that's a negative, a negative, a negative, right? So you can fill the whole chart in very, very quickly, right after testing 1 point on each one. I tapped to chose pi, could have chose 0 if you wanted to, if that's easier for you too, but something you can do in your head. 0 and pi are normally relatively easy things to calculate in your head, right? Okay, a positive graph that's getting more negative looks like this. A negative graph that's getting more negative looks like that. A negative graph that's getting more positive looks like that. A positive graph that's getting more positive, and a positive graph that's getting more negative. And I'm going to embarrass Joe here. I like what Joe was saying on his graph. He was saying local max, local min, or maximum. You were saying stuff like that on your last test. I thought that was good. So. All right, let's graph this bad boy, and then we'll move on here. I'll give you guys one to try yourselves after this. Okay, how much time do I have? Oh, yeah, lots of time. Look at this. You guys can do a graph in 3 minutes, I hope. Okay, so let's get my graph here. Now, I'm going from 0 to 2 pi. My hint is for you guys strongly. You're going from 0 to 2 pi. Can anyone tell me what every single sort of dash on my graph should be in this case? Right? Yeah, pi by 4 for sure. Okay, because everything here is a fraction of divided by 4. Okay, so just make your graph good. Now, also, and I'm going to embarrass Tyler because he's on his phone now, but also I'm going to embarrass you because this is how your graph went. And I'm embarrassed in front of the class, and I apologize for this. And this graph looks something like this. Okay, so what's the issue with that graph? What's the issue with that graph? You guys don't know what's an issue with me?
None of the points
This
are.
thing has the scale, okay, is the issue. And that was even an exaggeration. Your graph actually like this. And you had like this much graph paper to use, okay? So if that's the case, so there's this much, okay? But still, the idea is, what I was trying to say is, though, your scale doesn't be the same, right? So if you're counting by pi by 4s going this way on your graph, right, you don't have to count by pi by 4s north and south, right? Sorry to embarrass you for the last, okay. All right, so here's our graph comes. That was sort of mean, I'm sorry, I don't know what I apologize. Okay, it's because we got this focused. Okay, sure. Okay, so if you don't have a piece of graph paper in front of you, it's what's going on here? If you don't have a piece of graph paper in front of you, I strongly recommend to get one or borrow one from your neighbor. Okay, this graph, if I give you one like this on your test, this should be a beautiful graph. What's my maximum value in this graph going to be?
Root.
Good, what's the minimum value going to be?
Negative root 2.
Negative root 2. So I can just make this graph go from positive root 2 to negative root 2. You can put it wherever you want. So here's 0, 1, 2, 3, 4. No. There's pi by 4. There's pi by 2. There's 3 pi by 4. There's pi. There's 5 pi by 4. There's 3 pi by 2. There's 7 pi by 4. There's 2 pi. 1, 2, 3, 4, 5, 6, 7, 8. There's root 2. 1, 2, 3, 4, 5, 6, 7, 8. There's negative root 2. All right, and here comes a beautiful graph. Okay, so my original point was 0 and 0. 0 and 1, wasn't it? Oh, sugar. Dang nabbit. So 0. There goes my beautiful graph.
Usually there's a bit of estimate.
Okay, there's 0 and 1. Okay, pi over 4 was at a max at root 2, we said. Then we had 3 pi by 4 was equal to 0. Then we had 5 pi by 4 down to negative root 2. We had 7 pi by 4 at 0. Then we had 2 pi at 1 again, which is up here someplace. Yep. Should I miss one?
They think they're off between the pile 4 and pile 2.
I don't think so.
3 pile over 4.
So we got this 1, 2, 3, 1, 2, 3. Everything's counted by 3 lines. 1, 2, 3, 1, 2, 3. I think we're good. I think we're all right. Okay, so connect the dots then. So the first one's going to be looking like this. Then from here to here, it's going to be downward like this. From here to here, it's going to be upward like this. From here to here, it's going to be upward like this. From here to here, it's going to be upward like this. Again, you can draw your arrows on there if you want to. So that's what sine of x plus cos of x looks like. Okay, the one in your assignment is a little bit more difficult than that, okay, because there's sine 2x or cos 2x. I think one of them, I think. One of them is, isn't it? And the other one has tan of x in it, okay? I'm going to do a graph like the tan of x one right now for your second graph. Okay, what I want you to try and do as best you can, and Michael will help you, okay, is to do the first two derivatives and solve the equations. Okay, so 0 equals your derivative. That's going to be the tricky part for you guys, okay? I stopped the video because it's 35 minutes ago. And that took me 30 minutes to that graph.